everybody. Thank you for joining in. On behalf of TCSI and I, Rahul Soni, delighted to welcome you all to this masterclass on AI Demystified, what it is and why it matters. AI is a term we hear almost every day, from news headlines to the apps we use. But very often it feels like a mystery. What exactly is AI and why does it matter so much today? That's what we are here to uncover. In this masterclass, we will talk about AI demystified, breaking it down into simple ideas you can connect with, exploring why industries everywhere are adopting it and how it's creating opportunities for learners and professionals like you. And down the line, we will also introduce you with our successful program titled as Hands-on AI for Real-World Applications in collaboration with prestigious IIT Kharagpur, which gives you not just knowledge, but the skills to put the AI into practice. With that, let's get started. And I am delighted to welcome our esteemed guest for today, Dr. Jiaul Paik, who is an associate professor at the Department of Artificial Intelligence at IIT Kharagpur. He has been working in this area for more than a decade and has published several research articles in top tier venues on AI. So let's embrace this evening with open minds and hearts. We welcome the esteemed speaker for today. Welcome, sir.
Thank you so much.
So, without further ado, I would like to ask our first question to Professor Paik. So, could you please give us a quick overview of what artificial intelligence really is and why it has become such an important field today? And also, if you can take us through the fascinating world of AI in this masterclass. Over to you, sir.
Okay, so very good afternoon, and thank you so much, Mr. Rahul, for your kind introduction and asking this question. So I have a few slides on this particular topic. So I'll directly go to the slides to explain what is AI, why this is important, and how things are typically done in the modern days. So I share the slides, and then I think I'll start talking about those things. I hope my slides are visible to all of you.
Yes, sir, visible.
Okay. All right. So once again, thanks for joining this session, and thanks again, Mr. Rahul, for the introduction and taking the initiative to start this session and so on. So to answer the first question that Mr. Rahul has asked, so I'll just directly get into the crux of the subject matter. So the question that often we have is that what is AI? Okay, so there are a lot of definitions of AI, and different definitions from different perspectives, from different angles, and so on and so forth. So I'll try to give you a very informal definition of what is AI. So basically, through AI systems, we would like to more or less achieve the human intelligence. Okay, so we'd like to make systems, the computing systems in particular, which will mimic or at least try to mimic human being and do the regular jobs that a typical human being will do, which requires some sort of cognitive abilities and so on. Something like learning, reasoning in a particular situation, problem solving, and often problem solving in an unknown situation, for example, something that you have not seen before. So these are the three things that we're expecting from an AI system, which is very fundamental to human being as well. And we generally try to sort of mimic through the systems these attributes of human intelligence. So I just like to start with the cricket analogy, and I just use this particular analogy or the example to illustrate when you call a system intelligent and so on. You think about a cricket match. A batsman is batting and the bowler is bowling, and there are a lot of fielders and so on and so forth. Now, what happens in a situation like this, that first of all, we have to classify a particular thing. It's called classification, or the fundamental building blocks of any AI systems. Okay, so in this case, when the batsman is seeing the ball, he has to judge whether the particular ball is in swinger or out swinger or straight or something like that. So the nature of the ball has to be uh, has to be identified first before you take any action. So that we call this classification. Whatever information that you receive, you try to classify into one of these categories that you know, and then accordingly you take action. So once you classify this, for example, this is an in swinger, then the reasoning comes into picture. And the reasoning, basically, the purpose of reasoning is that you are going to take some actions based on the reasoning. Okay? So is it a 30th over? So then probably you don't want to take any risk and you would like to defend. Okay, don't want to hit for a 6 or 4 or something like that. With 45th over, you probably would like to hit the ball as hard as you could. And for example, you try to hit a boundary or something like that. Okay. And then, in similar situations, when you encounter the similar situation in future, you probably use the same kinds of things again and again and again. Okay, you did something before, then you would like to do the similar thing again and again. That's called reinforcement. Okay, so three fundamental things in an AI system: classification, reasoning, and the reinforcement. So some of the things that you often do in decision making, for example, is the generalized problem solving. Okay, so there are various kinds of problems that we deal with. One of them is planning problems. Now you think about this one, the rubric cube problem solving. So we have a starting point, a starting configuration, and we would like to reach to our destination configuration. So which way basically we should proceed? Okay, so that's called the planning problem. We have to plan the sequences in such a way that we can quickly and efficiently reach the target that we are trying to achieve from the initial state or the initial configuration. Now, the other very common situation where we basically encounter this is the reasoning under uncertainty, for example. So think about the situation that you have several things like a particular season, it's raining, then, so the season can create some sort of allergies and so on and so forth. If it is raining, then whether something is grass, this umbrella is there, or dog is barking, and something like that. Okay, so a lot of things can come into picture. And as a result, you have to reason for a particular thing, a particular situation, using all these connections that you know and that is available to your knowledge. Now, sometimes we do also things in combination, for example, reasoning plus decision making. Now think about the game of chess, for instance. So when an opponent moves, then we try to judge what the opponent has done, and then we try to understand the consequences of a particular move that I'm going to make. And that will basically come from the reasoning process. So first you apply reasoning to decide what would be the possible moves that you can make. And then based on the best guess or the best possible thing that you think at that particular point of time, you take the right decision. Okay. So these are some of the common things that we human beings do, and we do seamlessly without even thinking about how we are doing this particular thing in a particular situation. Okay. Now, how to test whether a particular AI system, the artifact that we build, is intelligent or not. So one of the main contributors, I think, the person who initially told that AI could be built using computers, is Turing, Alan Turing. Okay, so he proposed a test called the Turing test, and it goes something like this: that you have three different rooms. In one room, the human interrogator is sitting. In another room, is the responder, human responder is sitting, and in another room, an AI system is there. Okay, but the interrogator does not know which room has the AI system and which room has the responder, human responder. So what he will do, the interrogator asks a question, okay, and then he gets answers from both human and machine. You have human and machine in two different rooms. And from the answers, if the interrogator cannot distinguish which room has the human responder and which room has the AI system, then we know that AI system is actually an intelligent system, because this is as good as the human being, the human responder. Okay, so in the interrogator, being a human being, is not able to distinguish the system from the responder. So that was one of the most popular tests to judge whether the AI system, the system that we build, artificially intelligent or not. But frankly speaking, we do not really use this test to judge the intelligence level of an artificial system or the artifact that we build. There are many systems now which passes the test of the Turing test, but still we cannot say that whether this test is foolproof and can judge then whether a particular system is artificially intelligent or not. So I'd like to talk about a brief history of AI, although this is clipped history because the history of AI is very long and I won't be spell out to tell you the entire thing. So rather what I'll do, I'll talk about the clipped version of it. So in 1950s, the question came that whether machines can think. Okay, that's the question came. In 1956, then some people in Dartmouth conference took it further. In 1970s, the AI took its peak. It's called AI winter. Sorry, this AI winter means the abrupt halt of AI development. So between 1956, 1950 and 1970, there are a lot of effort people put to develop AI systems based on whatever knowledge available at that particular point of time. Okay, but it seems that the problem was too tough and people failed to sort of mimic even the basic level of human activities through the AI systems. Okay, and as a result, progress was not that great. People are not moving anywhere. So this kind of people started thinking about taking different routes, and kind of halted the AI developments. So then 1990s, because of the web and other things and availability of data, so people regenerated the interest in AI and some development took place. Then in 2010s, at that point of time, some people, they took it further and they developed systems which did impressive performance on tasks like image classifications and so on and so forth, sometimes matching the human level. And that basically brought the AI, the modern AI, into forefront. And the modern AI means the data-driven AI, where the data is the master for everything that we do. And then in 2017, the rise of large language models as a sort of in the form of transformer network, which kind of changed the AI scenario. And from then onwards, the rise of large language models and generative AI came into picture. And what we see basically today, the ChatGPT or the other large language models and so on, so essentially based on the idea that was invented in 2017. So most of the work that we do or see today is basically, it happened between 2010 and now, which is 2025. So when you talk about intelligence, of course, our primary target is to try to match the human intelligence level to some extent, of course, not entirely. So we broadly classify into three different categories. First of all, we call artificial narrow intelligence, then artificial general intelligence, and then artificial super intelligence. So now I will briefly touch upon these things. So in artificial narrow intelligence, the goal is to build systems, computing systems in particular, which will focus on the specialized tasks. Okay, one task at a time, for example. So text summarization, or for example, image classification, or for example, voice recognition, or face recognition, something like that. Now, AGI is many steps ahead of the ANI. So in this case, we like to build systems which will be capable of human level cognitive skills, many tasks simultaneously, and even some tasks where we do not explicitly train our systems to do so. Okay, something which is emergent behavior, they can actually infer from whatever knowledge that they gain. But unfortunately, although there is a lot of buzz about AGI, but as of now, no such system exists. There are some hits, but most of the things that we know is not really achievable through the current level of technologies. Third thing that we basically talk about is called artificial superintelligence, which is like many things more than what a human can do. Okay, but unfortunately, this is too speculative, too far away, and the current technology does not even suggest that this is even possible in near future. So as I said, AI can be general or narrow. So for example, something like this, a robot, which is, in science fiction movies, you have seen something like that. A robot will be able to perform many tasks simultaneously, just like a human being. Okay, that we call the general intelligence. Okay. On the other hand, a narrow example of narrow intelligence is something like a driving, So for example, automated driving, the system will be able to drive automatically without any human driver inside the car and so on and so forth. So this is an example of narrow intelligence that we often talk about. Now, there are a lot of tasks that we call narrow tasks in various domains. For example, in vision, computer vision, NLP, and planning, and so on and so forth. Okay, so in vision, in NLP, and planning, and so on. So we will come back later on to talk about specific tasks in vision, NLP, and planning later on. But for the time being, let's try to understand the connection between various things in modern AI. Okay. So I must say at the beginning, before I get into this particular slide, is that the modern AI is entirely data driven. Okay. So we as human beings not going to tell the rules of taking decision. Rather, we supply data and the machine learning models or the deep learning models will automatically learn the rules from the data itself. So this is all data driven. And as a result, we can break it down into several parts. The AI is the umbrella which covers everything. That's the ultimate goal. Then the machine learning is the next big thing, which is basically the engine which will focus on learning from data and the powerhouse for AI. Deep learning, something that we use almost every day on a daily basis, almost everything in AI now, is a subset of machine learning, which is based on artificial neural network. Okay, and we will basically briefly talk about those things in a few minutes. And then a generative AI, something which has generated considerable interest among people in recent years, is essentially a branch of the artificial neural networks, AI, where we generate new data very similar to human being. So the purpose of generative AI, of course, is to generate some new stuff, okay? So that as if the new stuff that the system generated is very much like an expert human being will be able to do so. Okay, so these are the broad things that basically we do in modern AI and so on and so forth. And of course, the course that basically you will be taking, the TCS ION course, the course will touch upon all these issues to a substantial degree, okay, both theoretical as well as hands-on. So even the more recent trend is agentic AI, which goes one step ahead of the other AI things that we talked about. Okay, so in this case, you have the four broad modules, the perception and goals. So there will be an agent, just like a human being. You can think about an agent is like a human being, but this is an artificially created agent. So the agent will monitor the environment and try to find out the objectives, pursue objectives and so on and so forth. Then the intelligence level will come from, mostly in today's world, the large language models. They will give you the reasonings and memory and etc. etc. And then the tools that will be used to connect the data systems, and they will enable actions. And then the agent basically will take actions depending upon the objectives and the reasoning abilities of the engines that it is attached with. Now, this is a circular process. The agent will go on and on, okay, and repeat the things and so on and so forth. Sometimes it may make mistakes. The next time it will try to correct it, just like we human being will do in a situation like, very uncertain situation. So the question then is, how does modern AI actually work? Okay, what are the building blocks, the technologies behind it, and so on and so forth. But I must tell at the very beginning that the modern AI has many, many parts, and it won't be possible to tell you all the stories in 10, 15 minutes. So I'll try to focus on the main building blocks very briefly. Okay. So first of all, when you talk about modern AI, there are three main pillars of modern AI. First, the data. So data is the main thing that will help you to design these smart AI systems. So this is the repository of knowledge and wisdom that we use. Second is the large models, which often called the deep learning models or the learning engine, which will learn the patterns from the data. And third, the computing powerhouse, and it's called graphics processing unit, which is a de facto and standard computing systems which we will use to train the models from large volume of data. Now, these are the three main pillars of any modern AI systems. We cannot build an AI system without even one of these things. Okay. So the large models are really the one that we ultimately produce from the data and training using the GPU computing powers. Now, this is all about learning from data, and learning means the machine will learn from data. Okay. So if I try to put the entire thing in a nutshell, then so data is basically will contain all kinds of pattern. Okay. And then the machine learning models will try to find out those patterns. There are a lot of algorithms available in machine learning. They will try to find out this pattern from the data. For example, if you have to summarize a text, then what are the clues that we're looking for in a text? If you have to answer a question, then how to understand a question and then answer from which parts? If you solve a particular problem, then what are the things that you need to solve a particular problem and so on. So machine learning algorithms will try to figure this out depending upon the applications and the problem that you are dealing with. So therefore, it will recognize these patterns and create the model. And the model is the ability, to learn the patterns from the raw data without any explicit supervision from a human being. Which all we give the data and the model will learn it. And once the model is ready, then you can go and apply for this one. So I just like to take this small example to distinguish between the human learning and the machine learning and connect these two together. Okay. So let's take this small example, something that we often do. So we have a situation like this, that we have the data about flight, the flight number, the amount of time that it can take to reach your destination, the cost, whether you are a frequent flyer or not, and then your previous history, whether you bought a particular ticket or not. Now, if you have something like this, if I choose a particular flight, for example, JE819, as a human being from this data, why did I choose it and how? That's the question. So generally what we do, if you follow the human reasoning as a human being, okay, what we do, we probably first look at cost. If it cost is too high, we say no, we're not going to choose any flight. Then once the cost is within our limit, then we say the arrival time then. Okay, is it going to arrive very quickly or not? Okay, if it is so, then we'll accept it. And if it is a frequent flyer, yes, then we will finally decide that one. Okay, if it is not a frequent flyer, then you say no. Something like that. The general things that basically we do to take a decision in a situation like this. A very common sense kind of reasoning that we do. And almost on a daily basis, almost everything that we do, we take some kind of the tree-based decision. We basically start with something, then yes, no, something like that, and then finally we decide. So this is we call the explicit decision making by a human being. But then, in this case, the earlier AI systems, for example, they tried to kind of encode the explicit decision making inside systems. But the modern AI systems, they do not do it. What they do, they simply automatically learn from this data. So what they will do, they need to have this thing called training set. You give the training set to them where you have all possible details. You have flight number, time, cost, frequent flyer or not, and then your target, the final decision that you want to take, whether you are going to buy a ticket or not, something like that. Then what the machine learning models will do, they will try to learn a decision function like that we have seen in the previous slide from this data automatically without any human supervision, without explicitly telling it that what to do and so on and so forth. And the learning algorithm that basically will help you to decide in a situation when you encounter something like that. I am flight number ZJ24, 4 hours time, 9,000 cost, frequent flyer. What should I do? Shall I buy a ticket or no ticket? Something like this. So as I mentioned that the main powerhouse of modern AI is machine learning algorithms. They will learn the patterns from this data. And this is more or less the broad pipeline of the machine learning systems. When we do machine learning, this is how basically we progress and we move forward. So first of all, we use the raw data, and the data will have all these patterns and so on and so forth. Then we have to clean the data, which is the second block in our case. You apply pre-processing because data often is not clean. You have to clean this data and so on and so forth. So you prepare the data and so on. Now, this generally goes in many rounds because cleaning process is not on one-off job. So you do repeatedly to clean and check and clean and check and something like that. So once you feel the data is ready, clean data and so on and so forth, then you choose a particular learning algorithm from all the things that we know, depending upon the data, your application, and so on and so forth. And then after many iterations, training, and so on and so forth, we choose a candidate model by training, and then we deploy the chosen model. That's the final model. Okay. So once you have the chosen model, then you can go and apply this in many different situations. Okay. So this is more or less the pipeline that we follow where we build machine learning systems. Now, machine learning can perform many tasks, and broadly, when you see, we have three things. It's called classification, clustering, and regression. So classification means that whether this is cat or not. Clustering means simply grouping. I am not going to tell anything about the groups, but I'm simply group the elements and so on and so forth. And regression is basically figuring out what would the exact value for a particular variable and so on and so forth. Now, again, this comes from the human learning process. Okay. So if you think about classification, for instance, we simply take an image, for example, cat, and we call it cat, and the system should be able to tell this is cat. Now in clustering, this is again grouping different elements. We are not going to tell which one is what, but simply we see the objects based on the textures and so on and so forth, and texture, shape, color, etc. We simply say that whether the elements of the objects are basically very similar looking or not, and we put them in a single group. A regression, basically, we are going to predict a particular value, the target value, exact values that we are trying to predict, and so on. Now, broadly, three kinds of learning that we often use: supervised, unsupervised, and reinforcement learning. So in supervised learning, generally what is done, that some data is given already to a system, where the explicit labels or the markers are available. And the best analogy that you can think about something like writing your exam. So you take classes for many, many hours. You learn many topics from lectures. You learn topics, you solve problems, teachers gives you some problems and so on and so forth. Okay, and that is how basically you learn. And now when you write the exam, you are actually answering questions from those topics that you already learned. Okay, so you already gained some knowledge, you solve some problems beforehand and so on and so forth. So anybody who has solved many problems beforehand, so they can actually do very well in the exam time. Okay, so therefore this process is called supervised learning process. We use data where the features and the target levels are available to you, and simply you learn the connections between the input and the output and then simply try to do it. On the other hand, in unsupervised learning, it's like kids playing something. So kids often do not know the many things about many things. So if you give them, for example, some objects of different colors, for instance, the kids probably do not know these are cubes, but they can identify colors quickly. So you simply group the objects based on colors, for instance. I do not need to know whether this is cube or this is something else, or this is a ball or something like that. Okay. So therefore, grouping things based on a particular attribute, okay, without even knowing what it is actually, is called unsupervised learning. There is no supervision on it. And the third thing is called reinforcement learning, which is not a supervised learning, not an unsupervised learning. So what happens is this, in a situation like that an agent or a system will take some action without even knowing the consequences of it. He doesn't know if I take this action, what is going to happen. Okay, this is going to be bad or good. Now, once I take an action, then I get to know the consequences of this action. Okay, for example, in this case, a rat is trying to come out of a particular block and trying to come out of this trap and so on and so forth. So what he will do, he doesn't know. The rat doesn't know that if I take this particular route, whether I will be able to reach the destination or not. What it will do, it will probably try to get the fast exit and then go as far as possible and then see if it is actually hitting any roadblock or not. If it hits a roadblock, then it will try to figure out any other route is available or something like that. So this is called the reinforcement learning, where we first do something, then observe the outcome. If it is bad, we change our action. If it is good, we simply continue to do that and so on and so forth. So broadly, these three kinds of learning that we often use in modern AI. So I'm just quickly skipping through this thing, just like labeling things, grouping objects, and so on and so forth. Now, when we talk about the modern AI, okay, so one thing for sure, you need data, you need machine learning models, and you need computing power. Three things that you need. These are three basic ingredients that you need. Now, on top of this, almost all modern AI models, they depend on a technology called deep neural nets, special branch of machine learning, which is the powerhouse of all modern AI systems. And in this, we have three major things, three titans of modern AI. So as a learner, your objective would be to master these three important pieces of technologies. And in this course, which ran previously and which is going to run again, we make sure that you master these three titans as well as possible. Both the fundamentals, the theory, the implementation, hands-on, and applications, and so on and so forth. So what are the three things? First and foremost, the deep neural networks, the classical deep neural networks that we know, is at many layers. Okay, you have input layers, many hidden layers, output layers. And I believe most of you have this, picture before your eyes. You are familiar with this kind of piece of image and so on. So when you have the tabular data in a very nicely structured data and so on, you go for deep neural network, something like this one. Okay, the feed-forward neural network. Now the second important thing that is we use often is called convolutional neural network, or CNN in short. And this particular network is used for images and videos. Whenever you do something with images and videos, video recognition, image recognition, something like that, then we use convolutional neural networks. And finally, the transformer model, which is the backbone of all modern generative AI systems, be it ChatGPT, Llama, or something else. The transformer model is the backbone. You cannot do the generative AI without transformer. Okay, it's originally invented for languages, but now people are using it for all kinds of things: videos, languages, images, and so on and so forth. So therefore, your focus should be on learning these three important pieces of technology. Okay, writing codes in PyTorch or TensorFlow, and trying to get things done. Okay, so I think I have given you two important things: the overview of AI and some technologies behind modern AI and so on and so forth. So we're going to take a small break, and then I'll come back and talk about why it matters and what is the future of modern AI, what are the hits and what are the misses and so on. So I now hand over to Mr. Rahul.
Thank you, sir, for this exhilarating masterclass till now.
Thank you so much.
See in the chat box as well, many of you are asking about the how you can upskill from the best institutes and how you can do that. So I have an answer for that, and maybe sir will add more into that with his expert comments. So as I mentioned when I started this masterclass, that we have a surprise for you. So we are thrilled to announce that the launch of Cohort 4 for our online certificate program developed by prestigious IIT Kharagpur in collaboration with TCS ION is already open. So after the successful completion of Cohort 2, we are now ready to welcome new learners to this exclusive course focused on hands-on AI for real-world applications. So this program is designed to equip you with essential AI skills, a blend of practical experience and theoretical knowledge. So this point, sir has also mentioned in his masterclass as well. We will be focusing on both the things. There will be a comprehensive learning. The course emphasizes 80% hands-on learning with real-world AI applications and 20% theoretical insights, live sessions with IIT faculty and industry experts. And the learning approach will be like is built around practical exercises like projects and industry case studies, giving you the opportunity to apply your knowledge in real world scenarios. So you can see all the details on the screen as well. My EV team has already made the slide up. Okay. So if you talk about who can apply for this course, that's a very valid question which most of the audience have asked. So undergraduates, postgraduates, and freshers with basic programming knowledge, Python is preferred, and the concepts, and advanced mathematical background looking for a career as an AI ML engineer can apply for this program. And there is a good news for non-IT people as well. You can also apply for this program. So that's the reason why we have asked in the beginning of the program, the beginning of the masterclass, that from which background you are from. Are you from IT or non-IT? So this is a good news for both of you. If you have Python knowledge and extra AI knowledge, that's good. If you don't, and if you don't, we also provide you that kind of course as well with respect to Python. So if we talk about the certification, so once you complete this course, you will receive a certificate from IIT KGP and TCS IN along with career support to help you advance professionally. Okay, so if you talk about the potential job roles which we have mentioned here, it can be like machine learning engineer, deep learning engineer, ML architect, AI engineer, GPT-3 developer, data science engineer, So these are the main roles which we have listed down here. There may be more roles for that when you will apply for this course or click on the link which we have posted in the chat box. Then you will know that what we are covering in this course. Okay. So after this, can we go to the next slide, please? Okay, so we have this QR code as well. You can directly take the snapshot on your mobile phones and register for this program. And the cost which was mentioned in the slide was let me check, 7,499. So I think it's less than your pocket money these days. To upskill yourself, that's a very nominal amount. So please note the important dates as well. So cohort 4 will begin from 25th of October and it will go on till 24th of January. And in case if you face any problem while registering for this program, or in case if you have any other doubt, you can reach out to us at info.tcsinhub@tcs.com. So I think hurry up guys, you can register for this course and upskill yourself in the job market. Sir, you want to add anything related to this course?
So the other thing that I'd like to add is that the course is pretty hands-on. So for everything that you do in theoretical sessions, you will have hands-on sessions on that, so that you can actually build your own systems from scratch as well.
Yes, sir. Thank you. I would like to hand it over again back to. Please continue with the masterclass.
The next part of this talk, I'm going to talk about why AI matters in today's world, and then what are some of the challenges that we still face today, serious challenges, and what can we do about this. So, simple question for this, why does AI matter? So the simple answer for this, basically simple answer is it is everywhere, almost everywhere. So if you look at, for example, the web search to, for instance, the voice recognition to your mobile phones, in healthcare and so on and so forth, it is almost everywhere. It is not that we have solved all problems, but it already reached in almost every discipline that we know, right from education to healthcare and so on and so forth. And I'll try to give you a glimpse of some of these things that is happening today and what are the things still we need to do. So first of all, AI is heavily used in precision medicine. So in precision medicine, what happens is that the medicines or the treatment that is typically given to a patient is very personalized, in the sense that the treatment is given based on what exactly the patient needs, no more, no less. And in this case, the data, many things about the patient is typically analyzed, and then the appropriate medicines or the diagnosis or the test and everything is basically prescribed. In precision agriculture, the robots are heavily used now. For example, right from identifying a particular disease in a plant and then spraying the right pesticides or putting right amount of water when this is getting dried up, or for example picking things up from plants and so on and so forth. Almost in everywhere the AI systems are heavily used nowadays. In online retail, which is I think one of the most widely used areas where the AI systems are heavily used, for instance, the product recommendation, or for instance, judging whether the product review is good or bad automatically or something like that. Social media is another place, as you know, almost everywhere, analyzing posts, recommending friends, and so on and so forth. In planetary missions as well, huge volume of data is typically analyzed, and then accordingly the decisions are taken. And in assistive technology, for instance, if somebody has difficulty in talking or listening and so on and so forth, the AI systems are heavily used. They can assist people to answer questions. If somebody is not able to type, the AI systems can actually dictate what it is, and so on and so forth. So there were many areas, almost in all areas, AI systems are heavily used, and partly in some of the areas, challenging areas, they're partly used, and we're hoping that with the advent of many models, many new models, and so on and so forth, we will be able to build more systems on that areas. So some of the prominent areas in AI is natural language. One of the prominent areas is natural language processing. Okay? This is one of the things which generate a lot of attractions and interest. And in fact, the ChatGPT is basically primarily a natural language processing system based on deep learning technologies. Okay, so for instance, information retrieval, you ask for something and the system will provide you the right piece of information, books, papers, articles, blogs, etc. Sentiment analysis from text. So if you have text, then you would like to know whether this is positive, negative, bad, good stuff, and so on and so forth. Information extraction, you have raw data, for instance, a very long piece of text. From this, you would like to create a manageable tables, tabular data, which you can quickly take a look and take any decision that you like. Machine translation, for instance, from one language to another language, and then question answering. You ask a question, and the system won't give you long piece of answer or the whole document or book, but rather simply tell you the answer of the particular question. So these are some of the areas where AI systems are heavily used. And we generally now in today's AI systems generally get very satisfactory performances. Another area is computer vision. So here what we do is basically we try to, mostly from images and videos, we try to understand the images and videos and try to make sense out of images and videos. So for example, think about a situation like this. You have a scene involving a lot of things, human being, trees, roads, monuments, buildings, lights, and so on and so forth. So it's called segmentation problem. From a scene with many, many parts, we try to segment which particular thing is what. And this is extremely important when we build the automated driving systems, automated car, and so on and so forth. Because it needs to understand that whether a human being in front of the car, or there is a road or obstacle, and so on and so forth. So self-driving car is a classic example of the application of AI, where the car will have a camera on top of it and the sensors, and which will take pictures of the road ahead. And the AI system will try to analyze these pictures to try to understand whether the road is clean or there's an obstacle or anything like that. And accordingly, the system can take a decision whether it should stop or take diversion or take a return or something like that. Image captioning is another area where AI systems are also widely used. So you give an image and then you come up with a natural language description of the image, and without even explicitly telling you this is the corresponding caption and so on and so forth. Okay, so that helps. In fact, there are quite a few work where you can actually type a textual description of an image and the systems can actually generate the corresponding image. For example, you can ask something like, give me an image with a player hitting a six in a field with a lot of people, so on and so forth. And the system will try to generate the corresponding image from the textual description. So these are some of the developments that has taken place in recent years in computer vision area. Now, even more challenging, like the game playing. So Go is a very challenging game, and people often call more challenging than chess game. So this is a basically board game where you make moves and to kind of win the game. So in this case, you make the move with respect to your opponent's move and so on and so forth. So what would be your next move with respect to a move given by your opponent? So this is the another area where, in fact, the AlphaGo system that DeepMind built is actually beaten the human champion Go players. The Another big thing that we know is called generative AI. Okay, so in this case, they will generate the data, be it image, text, and so on and so forth, as good as a human being. You must have used ChatGPT like a system where you type something, for example, you are asking that, write a letter for me which will be containing this, or you are simply telling, write a letter for me with this particular theme and so on and so forth. And you often see that ChatGPT is actually producing a very nicely structured letter with all the contents that you are looking for. So this is an example of generative AI. It is generating a new stuff from a small little prompt that you provide into the system. So in generative AI has a lot of applications, and I think is one of the most prominent and happening areas in modern AI. And it has a lot of applications in art and design. You want to create artistic images and so on. You want to create new music, for instance. You want to create new content, the virtual worlds, even designing the fashion products and so on and so forth. What would be the right, the clothes for an individual and so on. In financial forecasting, whether the stock market is going to crash or going to boom, and in which particular period of time and so on and so forth. Customer behavior analysis, where from the data you would like to judge whether somebody is going to buy a particular product or not. Demand forecasting, healthcare diagnosis and prognosis. You can analyze the images, for example, the MRI images or the X-ray images to figure out whether there's any abnormality in a particular patient and so on and so forth. Or from the symptoms, whether you can suggest that this is the particular disease and the corresponding treatment and so on and so forth. So there are a lot of areas where generative AI heavily used. In some areas, in particular the safety critical areas, people are still skeptical about it. There's some progress and a lot more progress we have to make, but we are actually going in that direction. So I'd like to show you this small example of emergent behavior. And this is something, this is one of the hallmarks of the AI systems that we have been thinking about for quite some time. Okay, so if you look at the leftmost part, we are giving some examples: 2 to 4, 3 to 9, 4 to 16, 25 to 1. So we have given enough context for the system, the 2 to 4, 3 to 9, 4 to 6. Now we are not explicitly telling the system that what's the operation that we are going to do. So it's like a square, we are squaring the numbers. Okay, so from these examples, the AI systems can actually tell the square of 25, the number. And this is called in-context learning. We are not explicitly telling what the operation is going to be, but rather we are giving some examples, and we are hoping that the AI system will be able to pick the right rule from the examples and give the correct answer. Now prompting is another thing, and generally we do. Some of you might have some experience with prompting with ChatGPT. So you have some question, you provide the model answer and so on and so forth, and then the system will try to answer new questions and so on. Now if you look at the middle part of it, what you see is that the questions are given, some answer is given. The system may not be able to answer these questions because the question will involve reasoning, understanding the question from the natural language and so on and so forth. But then the same model can actually solve such kind of problem with little bit of more tuning, which you call chain of thought prompting. So in this case, we are not only telling the answer, but also telling some sort of process of finding this answer. Now, if we tell the process of finding this answer from a natural language description, the same system is actually able to tell the answers correctly. Okay, so this behavior is pretty common, which we call emergent behavior of modern AI systems. Now, some of the other applications, for example, lesson planning, where you ask for a particular thing and it will produce you the right lessons in a particular situation or a particular topic. Okay. So concept reinforcement, for example, you are trying to explain something to a learner and you are trying to give various kinds of scenario so that the learner can actually understand the concepts well. So the modern AI systems can actually able to pick out some examples for you, which will explain the same topic from various different kinds of things. Okay. So next, multiple levels of explanation. Somebody is a learner, is not able to learn a particular thing. He needs many perspectives for a particular topic. The AI system can provide various kinds of perspective from various angles to explain things relatively better. There are other problems like problem solving is also pretty common, very well done by modern AI systems. So this is a geometric problem. So you can actually give a problem, this one. So this one proof where it is simply using the algebraic decomposition, algebraic approach. The another is a geometric approach, it is trying to explain and so on and so forth. The another rearrangement using visual puzzles and so on. So you can see that close proximity between some of the human reasoning process and the AI systems that we see today. So these are some of the applications, and there are many applications. For the paucity of time, I was not able to tell you. And one thing that it tells is that we did achieve many things in the last few years, which we did not achieve till like 1970s and so on and so forth. Okay. In some cases, very attractive performance and so on. But still, there are miles to go. There are many things where we need a better system and for good reasons. First of all, ultimately we are targeting artificial general intelligence, but we are not yet there, very far away from artificial general intelligence. And in order to solve this, we need to solve plethora of problems. We need to solve visual perception, audio perception, motor skills, natural language processing, which has been done very successfully, problem solving, navigation, moving in a particular situation, creativity, which is even more challenging, and then social and emotional engagement. So if you really like to build AGI, then we need to basically put all these things together in a single device. And this is far away from what we are right now. Second, and one of the most widely discussed things called bias in interpretability. Now, the current state of machine learning is something like that. You give some data, you get some output, and that is done. More data, better results, and so on and so forth. But when things go wrong, we do not know why something is going wrong. But in human learning, we can actually tell why things went wrong and we can correct our mistakes. But with the current machine learning state, we actually cannot do that. There is some progress that we made, but that's very little progress. So, and these systems are widely used in many different areas. For example, in automated driving, which is extremely safety critical area, and building news articles and so on and so forth. In chess playing, for example, game playing, and in machine translation from one language to another language. So these systems are heavily used in many different kinds of areas. So if you fail on machine translation perfectly, all right, no problem. Possibly you can afford that. If you fail on a chess playing, you can still afford that. But if you fail on automated driving, for example, there will be a catastrophe. Okay. So in some situations, we need more safety. So here are some examples of safety and machine learning algorithm bias. So think about Tesla, for instance. There is a recent news where the car actually made an accident with. So because of this autopilot failure and so on. On the right side, what you can see, the bias in algorithms. So clearly one can see is that the lighter males, they are being predicted with higher accuracy compared to the darker males, and the performance of darker females are even lower. Okay. So what this tells is that some kind of bias over one over the other one, and that may be because the data bias. The models are heavily trained on data. The data tell you what is going to be the model. If the data is bad, model is going to be bad. Now, the other thing that we often encounter is called hallucination. So this is an example of a problem where the student is actually asked to solve a problem about 3 lines, L1 and L2, 2 lines perpendicular to each other. Then another line, L3, is perpendicular to L2 and so on and so forth. And the student gave an answer. So we ask the system to verify whether the answer given by the student is correct or not. So here is the situation. So this is the problem statement. L1 and L2, they're perpendicular. L3 is perpendicular to L2 and so on and so forth. So now if you simply go by this one and so on and so forth, it goes something like this. Okay? So that should be your ideal answer. But then when we actually pose this answer to the AI system, for instance, then what is happening? So it is actually analyzing all these answers. Okay? And it is telling why the student's reasoning is incorrect. Okay? And the way it is telling you seems little convincing. In particular, this will be convincing to a newcomer, new learner who doesn't have much background in a particular topic. And that situation is basically, we call it hallucination. It is trying to tell you something which is not correct in a very convincing way. And this creates more difficulty for a newcomers or the new learners because they are not in a position to judge whether the AI system, what it is telling you is correct or not. The second example of hallucination is something like this. It's a little more complicated. So this is a question posed to an AI system and it was asked to solve this particular problem. So algebraic equation and exactly 10 solutions and you list the solutions. So this is the response from the AI system. It is telling that this is exactly 10 solutions. I'm not getting into the right or the wrong thing in it. But then the next question, the same question we posed, the same equation that you are posing, now you are telling that prove that it does not have more than 2 solutions. It's again proving that same thing. Okay? The next question you are posing, the same question, but then we are basically asking it to prove that it has exactly 2 solutions. And then it is also proving the same thing. Now, the equation is the same. There can be one answer for this one. The moment we are asking it to prove 10 solutions, it is proving it. The moment we are asking it to prove 2 solutions, it is proving it. The moment we are asking it to prove less than 2 solutions, exactly 2 solutions, is proving it. So all 3 answers cannot be correct. And it is trying to prove everything is correct. So this phenomenon is called hallucination in AI, which is a pretty common phenomenon and something that is still a challenging areas of work. Now, lesson planning, you look at the lesson planning, it's a very attractive thing. We are asking for something, we're asking, give us some lesson plan for a particular topic. It's a very attractive, catchy looking things, but it's actually gibberish. It doesn't tell anything. It's far away from the actual stuff. Okay? And it could be misleading to newcomers, new learners. Okay? Because a system will be helpful to a learner when it can tell or it can actually teaches you the right thing, not the wrong thing. And in this case, it will create a lot of problems. The other thing that we can think about something like this, that this is the question that a circle passes through 3 points, find the equation of the circle. So the human solution will be much more detailed. When we teach something to kids, we'll probably tell all possible details to the newcomers. Find midpoint, then slope of AB, then this, then that, and so on and so forth. They're teaching all possible aspects so that the learner can learn, the newcomer can learn all possible things and actually grasp the concept well. But the AI solution is a bit more tricky. It skips many steps and therefore, although it probably gives the right answer, but doesn't teaches the learner how to solve a particular problem. We are not yet there and we need many more things to solve these problems. So that's it from my side. Thank you so much for listening and I'll be happy to answer any question that you might have.
So we have a lot of questions. We will take the 4 or 5 relevant questions. And thank you for this exhilarating masterclass. Let's take the first question from Dhanashri. Sir, can you please explain multimodal AI and what are the scope after learning multimodal AI entirely? What is the scope for that?
Yeah, that's a very good question. In fact, multimodal AI is something is extremely powerful and extremely popular as well. So to put it simply, multimodal AI is an AI system where you use various kinds of data in a single system. For example, you use language, you use video, audio, image, etc., etc. So all kinds of things basically use. So what used to happen earlier, that for different kind of data, for language you have one model, for video you have another model, for text, for image you have another model, and so on and so forth. So you have separate models for separate things. And then the challenge was basically to integrate all of these things in a single thing. But now the multimodal AI very smartly deals with all of these things using a single model. So therefore you don't have to integrate separately later on.
Okay, thank you, sir. So Aarti Joshi is asking, I think she is a faculty member in some college or institution. How will the higher education institutions or universities and professors affected by AI and how they can maximize the use of AI in their daily work?
Yeah, this question is also very like relevant for me as well. So we often encounter this thing on a daily basis. Okay, I answer this question. So some of the issues I actually touched upon in my talk at the last part. So, for example, I teach computer programming and also on so forth. So most of the regular computer programs students can actually solve using AI systems today. But when the programming problems gets a little bit challenging, then the one issue that you often face is that we get something from AI systems for sure, but we are not able to verify whether the solution is correct or not. So verification process is an important part and that takes time. So that is one area we should not be accepting the solution as is, but we take this as a clue and then basically try to verify it. The other thing, for instance, we can actually use AI systems to kind of create challenging assignments. Okay, you can basically see which problems can be solved very easily. You can create challenging assignments for the students and so on. For regular things, you can actually use AI systems to evaluate the students and so on. You can use AI systems to figure out the materials for a particular thing in a particular situation and so on. So it's kind of, the modern AI is not in a position to replace human being for sure. Okay, but you can use this as an assistive tool to help us prepare better materials, better teaching methodology, better assignments, better evaluation, and so on.
Thank you, sir. So we can take the last question. Shaurya Mittal is asking, what is your approach, sir? That which industry will be more impacted by AI? I think you have already covered this in one of the slides, how to leverage AI and in which and what are the industries which are affected by AI. But in case if you want to touch upon to this question.
Okay, so as far as I know that, so for example, some of the areas, for instance, in educational sector, in particular in so preparing questions and other things are basically heavily now done through AI systems now, regular questions, MCQs, and so on and so forth. Now, in IT industry in particular, that's what I came to know. I'm not fully sure about it. That regular small programming jobs were there. So AI systems are like basically heavily used in those areas. So other areas like, for instance, the sectors where we need clerical jobs kind of stuff, for instance, responding to a letter or writing a letter or maintaining a worksheet, balance sheet or something like that, in accounting and all, AI systems are heavily used.
Thank you, sir. So any final thoughts, sir, why students should take this course, or why should they upskill from such institutions, or if you want to add anything?
Okay, so yeah, thank you. So first of all, as I told many times, that whether you learn AI or not, AI will come everywhere. That is for sure. Okay, almost in all disciplines, AI is going to invent in some form or the other. Okay, and that does not mean that AI is going to replace us. Okay, the role of AI will be complementary. Some things AI will do, and something we have to do. We have to leverage the AI systems to get things done efficiently and as quickly as possible. So therefore, it is important to know the uh, the best technologies, best practices, and in a very practical way. You need to have a balance between the theory, the foundations, as well as the implementation aspect of the systems and so on and so forth. So based on my prior experience, this particular course gives you both flavors. It tells you, gives you the foundations, it gives you the hands-on experience as well, so that you can actually take it up and then build your own systems from scratch using your own knowledge. It also covers almost all aspects of AI and all aspects of AI from various different kinds of disciplines, from various kinds of angles, and then the future potentials as well, where these things can be applied. On the other hand, on top of this, you have the formal certificates once you complete it. And so that certificate will also give you a formal recognition that you have successfully completed the AI programs and so on and so forth. So I think the combination effect, the learning that you experience, both theoretical, practical, and so on, plus your recognition at the end of it will give you a good handle which you can leverage in your career.
Thank you for sharing that, sir. I think I want to reiterate, you mentioned that best technology and best practices from the topmost institutes. So here you are, you can directly click on the link. We have already illustrated all the details about the IIT KGP course in collaboration with TCS. Sir has already illustrated all the things, important points, and the cost is 7,499. So I already mentioned it's lower than your pocket money. So please go ahead. And I remember Revathi was asking about the QR code for the course. I would request my AV team to please share once again. And Revathi, you can also see the same on the thank you slide as well. You can directly click in your mobile and register for the course. Okay. Sir, I think we are running out of time. We already extended. But the way you were explaining, I think we all feel that if we don't have time constraints, then we would have definitely continued this masterclass for long. But sir also has some other commitments, then we need to wind up right now. So hence, on behalf of TCSIN, I would like to express my deepest gratitude for your outstanding contribution as a speaker in our masterclass today, sir. Your presentation was not only insightful, but also incredibly engaging. You captivated our audience from start to finish, and we all were deeply engrossed in the valuable knowledge you shared. So thank you once again, sir, and thank you, audience, for being part of this evening.
Okay, thank you so much. Thank you, Mr. Rahul. Thank you, the TCS team, and thank you, the participants. And I'm hoping to see, all of you in the coming course, the coming session.
Yeah. Thanks a lot, sir. Thank you once again.